Good morning. We're going to talk about the SUVAT relationships. Now these are a set of 4 equations that physicists use to link the quantities S, U, V, A and T. S for displacement, U for initial velocity, V for final velocity, A for acceleration and T for time. You see, using these 4 relationships, what we can do is we can calculate a 4th missing variable when given 3 variables. We do not need all 5. And so we shall begin with the definition for acceleration. You see, acceleration is given by the difference in velocity between 2 times divided by how long that difference has taken to occur. That v minus u over t is essentially the first equation of motion. It is more commonly seen through the rearrangement that occurs when you multiply both sides by t, then you have v minus u, and then of course you add u onto both sides, and you have v that is equal to u plus at. And this is the first equation of motion, and this is the first one that we're going to use. Of course, the second equation of motion, and my personal favourite, is the one that looks at the displacement. You see, from the relationship that displacement is, velocity, shall we say, is displacement divided by time, what we can do is we can rearrange this to have the displacement is velocity times time. Now this is correct so long as the velocity is constant. If the velocity is not constant, then this is no longer true. And these equations are especially useful when the velocity is not constant, when it is changing from one value, u, to another value, v. So to that end, we cannot have v as a single quantity in this equation. But what we could do is replace v with the average velocity. And that can be found the following way. The average velocity is, of course, equal to u plus v over 2. The average of any 2 things is basically equal to the 2 things added together and divided by 2. The average of u and v can be found by adding them together and dividing by 2. So if we substitute in the average velocity for where v is in this formula, then what we have is s equals u plus v over 2 times t. And this is the second of our SUVAT relationships. We want to go for another one. Well, what we could do is we could take this expression for v and substitute it in to the v of this equation here. So let's give that a go. So if we have s that is equal to u plus at divided by 2 times t, then we have this relationship here. Now, the first thing I'm going to do is I'm going to combine the u terms. We've got u plus u, that's 2u. So we have s equals 2u plus at divided by 2 times by t. We have 2 divided by 2, so that cancels out. But we still have to divide this side by 2. So we end up with the displacement is equal to u plus a half at, or brackets, t. We're going to now multiply both terms inside the brackets by the t, and so we end up with the displacement is ut plus a half at squared, the relationship that Galileo found by rolling balls down inclined planes. The proportionality between s and t squared is, well, very close to the acceleration. Of course, that half is in there as well. And now, a chap called Evangelista Torricelli, he realised that the equations of motion were not complete, that there is in fact another equation of motion that is missing from here. And the way that we're going to do this is by literally taking this one, and we're going to just multiply them together, because we can do that sort of thing. So, we'll start just here, if you follow. As is going to be a, which is v minus u over t, v minus u over t, multiplied by s. Where is it? Down here. U plus v over 2, u plus v over 2 times t. So So now we have to multiply out the brackets. Well, the first thing I'm going to do is I'm going to collect the denominator, because that seems to be a sensible thing to do. So we have AS is V minus U, U plus V, all divided by 2t, multiplied by t. The t is going. The two t's cancel out, you see, t and t, goodbye. Lost my chalk, going for another chalk. Here we go. So now I have this expression, I'm going to multiply both sides by the 2, so that the 2 appears over here. 2as equals v minus u, u plus v. And of course, I can multiply out these brackets as well. So I'm going to multiply out the v's, and I end up with 2as is equal to v squared minus uv plus uv minus u squared. And so therefore this and this cancel out. A rearrangement gives v squared equals u squared plus 2as. Now you may think that this is impressive, but let me tell you, the most impressive thing that I can do with the blackboard is this. With a chalk, I can draw little dots. Watch this. Wait for this. Are you not impressed? I'm impressed. Let's do one more.